When I begin to consider compound inequalities, the first and most important thing I do is to determine if my compound inequality is an AND or an OR compound inequality. There are fancier names, conjunction and disjunction, but we're going to stick with AND and OR. In our example, it's really easy to see that it's an OR, so I drop that word OR down, and then I just begin to solve each side of my inequality like I would any other inequality. So on the left, I would add 6, and I isolate the 3x term, so I know that 3x is less than negative 3. Divide by 3, and divide by 3. Since I'm dividing by a positive number, the sign does not switch, and I get x is less than negative 1. So half of my answer are all the numbers below negative 1. On the right-hand side, I subtract 8. That leaves me with a negative 2x on the left, less than or equal to negative 20. Divide by negative 2. It should ring a bell that when I divide by a negative, I'm going to have to switch the direction of the sign. So the second half of my answer is x is greater than or equal to 10. So if I look at my solution in terms of inequality statements, I have two pieces, and I have to include the word OR. It's a very important part that a lot of people forget. The last thing I can do is I can graph this on a number line. I know already what the graph should kind of look like, the two dots shaded toward the outside. So I'm going to put a reference point, I'm going to put a negative 1, and I'm going to put 10 out here, roughly to scale. Check what kind of dots I have. I have an open dot at negative 1, I have a closed dot at 10, and then I shade all the numbers above 10 or equal to 10, and all the numbers below negative 1, which represents my solution set to the compound inequality.